Hello guys, Green here and welcome to my new channel. I'm still not sure if I will add videos regularly, but for now let's check my newest build, the text display which you can see on my screen right now. Okay, so let's get started. Let's start with the features of this build. As you can see, it can be split into modules. One module is one letter or symbol. You can display anything you want there. That's also an advantage of this build, is that we have got a memory here, and you can change the memory to whatever you like. And in the memory there is stored how every character looks. So I can change anything. Let's say I want to change this T to some number. So let's say I want to change it to 5. So I changed it to 5 and now it says 5. I can change it to 2 or let's say 7, or let's change it to whatever age, which is 18. It works pretty well. Let's change it back to number 30 for T. So yeah, you can also change colors for each individual letter. The default color is obviously white, but you can change it to red, basically any color you want. Okay, so now that we checked the display, how it works, I will show you how to build it. Okay, so the design is really small and I try to keep it as cheap as possible, so you don't have to have a lot of resources for it, but in Factorio it really doesn't matter how many resources you need, because you can always have more. So what you need is the blueprint book that will be probably somewhere in the description of this video and maybe posted on the forums or something. Yeah, so we got this text display book. It has got 3 blueprints in it: the module, default memory, and empty memory. You don't need the empty memory yet, and so you can use only the first 2, but the empty memory is good when you want to display your own symbols there. Okay, so let's get started. Let's build the module. As you can see, it's the one module, one letter or one number or whatever you want. So let's place it, I would say, like here. You don't have to connect the pole that is there to electricity. You can build it whatever, like here or anywhere basically. But if you do connect it, it doesn't matter. You can leave it connected or disconnect from electricity, whatever works for you. So let's build this. Okay, so I will disconnect this one just because I can. And yeah, so the module by itself does really nothing, and there is no way to display anything here yet. But what we can do is we can connect our constant combinator, place it wherever we want, and connect it by green wire to this decider combinator, the rightmost decider combinator in the top layer, right next to the pole. Don't connect it to the pole, but connect it to the top section of the decider combinator. So basically like here, and yeah. You can check it's connected, like the wire is going here and then here. You can also use red wire if you want, but if you use red wire, you need to connect this and this by a red wire. You can leave it connected by both wires, it really doesn't matter, but yeah, I will keep it for green wires now. Now we can set our whatever we want to display here by using the black signal. I chose black signal just because it's one of the colors, but you cannot use actually this color for lights because the lights cannot be lit with black color. So yeah, you want to use it for colors, and I didn't want to use any of the letters or something, and obviously I don't want to use any of these because you may need them in your network. So I chose black signal, and yeah, so let's choose black signal, and now you need to set the value. It really doesn't matter now what you set the value to because there is no memory attached yet, so let's keep it on number 1 now. You can also add colors in the same constant combinator. I can set it to green and the result will be green instead of white. You don't have to use constant combinator, you can have like it connected to your circuit network and do whatever you want. Just input the black signal into here and you will be okay. So now what to do? We can connect the memory, but I want to show you how to build more text display modules. It's really simple, you can just place them as close as possible. You don't have to worry about spacing because this line, the last line on the left of each module, won't be ever lit. So it's basically like only this 5 by 9 rectangle and not this line. So this line acts as spacing. But I added it there just because it looks nicer if there are lamps and they are connected. You can remove these lamps if you don't want them to be there, but I think it looks pretty nice. So now you can just connect another combinator. You can just copy the settings here and connect it as same as here, and it will work for this one. But again, there is no memory yet, so let's take care of the memory now. As you probably saw, in each module there is one pole which has both wires connected, red and green. And when you build all the modules, all you have to do is connect them between the poles with both wires, so it's connected by both red and both green. These wires, the red and green wires, they are the memory lines. They will carry all the data from your memory. But we don't have any memory yet, so let's add new memory. Sorry, wrong blueprint book. Let's go for the default memory, which already has set all the numbers and letters, so we can use that. You can place this wherever you want, but it's good to place within the range of these poles, so I like to place them on the rightmost side, like here. My bots don't have constant combinators, I guess. Oh no, they are just somewhere else. Okay, so now we have memory. I will turn off this so we can see. There are 2 rows of memory. One is green and one is red. So you can just connect it, obviously green with green and red with red. As you can see, things are already happening here. We have 1, 1. It's like the 7-segment display style. So we can change this to whatever we want, let's say 13. We have 13 now. yeah, this text display can be also used as 7-segment display. You can also remove the lamps that are not used in 7-segment displays. It won't hurt anything, but make sure all the lamps are still connected uh, to this line and to this combinator. But you can also leave it like this. It doesn't matter. Okay, so now let's see what we can do here. Uh, we can set these up to like 1 is 1, 2 is 2, etc., etc., and 9 is 9. And if we set 10, it goes to 0. I decided to go like this because when you use 0 here, it does some trouble with the signals here. So I made a choice, and the choice is that when there is a signal that equals 0, it doesn't show anything. So to use numbers, you use 1 to 9, and then if you want 0, you just use 10. Okay, so letters are following the numbers now. So if I use 11, it's A, 12 is B, 13 is C. I will probably put something in the description or in the forums that will help you, like which number corresponds to each letter in the default memory. I can maybe also I had it somewhere. Yeah, I have these constant combinators with signals set already to letters and numbers. So I can probably just screen this and you can use it, or I can add it to the book, whatever works. Okay, so that's basically how you use it. As I said, you can place as many modules as you want. You can just go infinitely, just mind the biters so they won't eat your circuits. But yeah, you can do whatever you want with this, and yeah, you just need to connect all the memory poles between each other and connect any source of signal to this decider combinator. In each module, it's the one on the left side of the pole, so it's pretty easy to recognize. So yeah, I will now cover the more technical stuff, but if you want to build this, enjoy this, you can just close the video, and I will be happy if you use it and leave some feedback. But now for the more technical stuff and how it works, and how to program your own memory, how to use the empty memory or anything like this, I will just cover it now. So let's check how it works. I have built the default memory here and empty memory here, and also one segment, one module. So we can check on this how it works. Let me just connect the default memory so we can actually see what is happening there. And let's connect the one constant combinator with obviously green wire. Okay, so now it's ready to do stuff. So each of these lamps has one vanilla item from this screen assigned to. You can check it by just clicking on it, and there's this is wooden chest, this is iron chest, this is underground pipe, and this is pump, and this is stack filter inserter. It may seem a bit random, and it is a bit random, It's just because of the way how I was creating this thing, and I just filled first some of them, and then everything changed, so I filled another, and yeah, but every one of these 45 lamps has one different item assigned to it, and yeah, so basically when the signal with this item is greater than 0, the lamp will turn on, and obviously we just use colors here, so we can transmit a color signal on the wire as well. This last, it is also connected to the network just because it looks like there's the graphics of the connected lamp, and if it's like this stacked, it looks, in my opinion, a bit nicer than if we just have this removed and only lamps, and there is the connection missing, and I don't know, I don't like this look, I like this look more, so yeah, but these lamps aren't doing anything and they won't light anytime, so you can just ignore them. Yeah, so now I need to get on this line, on this green wire, I need to get every item that should be lit. So let's say we want to write an A. A looks like this. So we want like the one iron chest, one underground pipe, one pump, one small electric bowl, one requester chest, and so on, so on. But we don't want any storage tanks or wooden chests or rails, no, nothing from this. So I want like one of every of these lamps, of the items that are assigned to these lamps, to be present on this wire. Yeah, it's actually not that hard task, and basically uh, that's what this part does. Okay, now let's check the memory. Memory is basically, let's check the empty memory first. It's just the list of the items that are used for all the lamps, and also in the memory, both in the default memory and the empty memory, they are sorted like from left to right and from top to bottom. So you can see it's like wooden chest, iron chest, pipe, pump, stack filter inserter, and it's the same here. Wooden chest, iron chest, underground pipe, pump, and stack filter inserter, and so on. There's a second row: steel chest, storage tanks, trade rail, train stop, and this is everything that's here. Yeah, and so on. So it's a bit easier to know where certain items are because of this. Also, keep in mind that this line is 6 items long, and this is only 5 items actually because this lamp is not used. So the first row here is not the first row here, it's like the first row but not this item, and the second row here is the last item here, and these 4 items and these 2 items are from the third row, and so on, so on. But yeah, it should be pretty straightforward. And yeah, you have to set all these items to specific values so that this decoder actually knows if the lamp should be turned on or off for the given value of the black signal here. So let's check the values. They are pretty high. Some are still set to 0, but this is okay because in the default memory it's already set everything for you. So if there is 0, it's just because like you may want to change it, and you can, but I like it more when it's like all items there, but even if they are not used. The numbers are some may look like random numbers and stuff, but these are actually binary data encoded into standard decimal number. So how this works is this number is actually a binary number that is 18 bits long, and 18 is because of this. Let me just copy it and move it somewhere closer so we can check it. So, bots, please build it. Thank you. So, the first 18 signals are numbers 1 to 10 and or 1 to 9 and 0, and then A to H. And the second 18 signals are from E to Z, from I to Z, I would say. Yeah, so this is the number that you have to set on the black signal. And yeah, but because of the game limitations, the game is actually coded in 32 bits, and the 32-bit integer can hold only 32 bytes, but we need at least 36 bytes, 1 byte for each of the letter and number. So that's why I have had to split it and use like 18 from 1 and 18 from 2, and this is also why there are 2 rows of memory, one is green and one is red, so they don't add on this pole, because if you would to connect this with the same colored wire, they will just add up, so the 190,464 would add to this 260,799 and would create a mess actually. So I don't want that, so that's why I use 2 colors. Yeah, so we have 36, and yeah, so this is the first row. The green row is for the first 18, so it's for these numbers and letters, and the second row is for the rest of the letters. So if I would check the wooden chest, it's actually this number, and yeah, it corresponds to the top leftmost pixel. And basically what it is when you take this number, let me just take it now, and if you were to decode it, let's Google binary to decimal, or let's say decimal to binary. Just place the decimal number and convert, and binary is 101101 and then 10 zeros or something. Yeah, so that's basically shows if for the given signal if the lamp is turned on or off. I'm not sure if you can understand me, so let's check this. I made these templates for numbers and letters. This is the line that divides the first 18 from the second 18. And just ignore this. This is the... I can just destroy all this because I don't actually need this. Yeah, so the top leftmost bit or pixel is this, and basically how you create these numbers, these binary numbers, is you go from the last to first, and you write the numbers like so. Like if there is a lamp, you write 1, and if there is not lamp, you write 0. So this number is 1 0 1 1 1 0 1 0, and then 10 zeros because the 7-segment display does not have top left lamp. So you end up with this number 1 0 1 1 1 0 1 and 10 zeros, or 11 zeros, I don't know. But yeah, you end it with this number, and it is 18 digits long, and you take this number, you use it as binary number, and you convert it to decimal. And if you convert this number to decimal, you get 190,464, which is the same number as we have in this chest. Yeah. So it basically, this one box with this number holds all the data for this one lamp for the first 18 symbols here. And on the second line, there is the 260,799, which is basically the same, but in these second symbols. Yeah, so you repeat this process over and over for every lamp. It's a long process, I can tell you that, but when you finish and you didn't do a mistake, you end up with a data set like this and like this. So these are the 36 encoded characters into binary into decimal numbers. So yeah, now we just connect it to the pole or to all the poles, and yeah, that's it. So now we have the memory, and now let's check how this big mess of combinators actually work. So let's just follow the path of the signal. It's signal 1. You can see here output signals is 1, and it goes to this first decider combinator, and then to the second combinator, because you see it's like now here, and the output goes into this input. These first two decider combinators are just safety checks. The first one checks if the black signal is bigger than 0, and then just passes it. If it's 0 or less, it just ignores it. And also the second one just checks if the black signal is smaller than 47, and again passes it. So you can just put here 1 to 36, not any other number. Or you can place the number there, but it won't do anything, and it's just safety check to prevent like mistakes from like when you send accidentally a different number than you want, and then this will display something. Because if the check wasn't here and you sent like, let's say 200, let me just connect it like in the cheaty way, like this. It will just, for some reason, just show J. So, and you were like, what? 200 does not equal to J because J is like 20 or something. So yeah, but you don't want this, so that's why I added this safety check. If you don't want the safety check, you can also always remove it and just connect it straight up here, and don't forget, because there's also this line that leads to this arithmetic combinator, don't forget to add it from this combinator. But I think the safety check is pretty nice there, so I would suggest keeping it there. Okay, so now let's go to the third combinator. This combinator, or I would say these two combinators, basically decide if the number it is here. Let's just place there some good number like 11 for A. If the number is from the green part of the memory or red part of the memory, from the top or from the bottom. So if it is bigger or equal to 19, which is the first signal in the red memory, it just passes 19 into this line. And if it's less or equal than 18, it just passes it to this red line. I will just hide these boxes so you can see it actually, but I don't think it. I don't know if you can see, but yeah, it's pretty mess. So now let's begin with the below 18 because it's simpler. It goes by this red line into this arithmetic combinator. So yeah, you can already see here is input signals and output signals both are 11, so it's the 11 that is set here. Everything is okay. It just passed through all these decider combinators that basically only filtered values and prepared everything for us. So now the 11 goes here, and here begins the mess, because here you can see it goes by red wire here, and also there goes the green wire from green memory. It's important to use red wire here because I don't want this red wire to be connected to this memory part. So yeah. Okay, so this arithmetic combinator receives all the green memory. It does not receive any of the red memory because it's not connected to it. That's why we had to split it here. So we know now we are using the green part of the memory. And yeah, so here we have each value is byte shifted to the right by the number of black signal. And outputs each. So basically everything is byte shifted and returned. Yeah, so we have 11 now, and yeah, so we use this 11 and we byte shift each by 11, but not actually by 11, because as you can see there is also this red wire connected to this constant combinator, which adds -1, so it just simplifies. It adds -1, so we get 1 less than we need, than was the first number. That is because we want to byte shift, we want to get rid of all the bytes that we don't need, because if this is 11, it's like we want this number in binary, we only want the 11th number of it. So 11th number is, I think, 0 here for the A, because it's not lit. So we want the 0 from this number. So yeah, that's why we have to shift it by 10 to the right, and then this outputs connected to this input, and here we have modulo 2, which basically says for the rest number, because we byte shifted, the last byte is actually the byte we want, but there might be any excess bytes on the left side. So like in this case there will be like 10111010. The 0 last is what we need, so we get rid of all the ones and zeros before it, just, and we are left with the only number that we want. So yeah, this each again does modulo 2 and returns each. As you can see here, in the output signals we have all the byte shifted by 10 memory, and then we just do modulo 2 on every of it, and as you can see here, we get all the signals with number 1 on the end, and yeah, that's basically what lights up all these lights. Yeah, so it's that simple. It's just some binary data, and it just takes it from the memory, byte shifts it, and modulo 2. Let's check the other one. It's this one. If the number is bigger than 19, we first need to subtract 1 from it, and then do modulo 18. It's basically to make this 19, to make it 1. So we subtract 1, it's now 18. then do modulo 18, it's 0, and then we add again 1 number there, so it's back to the 1. So we basically convert this. I could use -18 here, but this setup will work in case there will be some third wire which isn't in the vanilla, or if I was to place the decoder also on the bottom and use red wires for the lamps as well. With this setup we can have twice the number of memory because we have green and red from top and green and red from bottom. And in this case, we can use the modulo much more than only -18. So that's why I used it like this. And also it fills up pretty nicely to this space. So there are no spaces in here. There is no blank row. I think it's pretty cool, and it does not slow things that much. It's only 2 ticks more, so it's okay. So now we basically have done -18, but in more complicated way. And again, it connects to the second byte shift combinator, which is the same as the first, but connected to the red part of the memory instead of the green part of the memory, and also again connected to the -1. So again, we would get -10 here if I was to do 29, which is equivalent of 11. So we are getting 11 here, and here is 10 because of the -1. And again, this is connected to the modulo 2 combinator. Yeah, so basically in the modulo 2 combinator there is already only the data that we need to display the number. So yeah, that's basically everything covered. There's only one combinator left. It's this arithmetic combinator, which is connected by the green wire from the input, and basically what it does, it's each +0, so it's like one-way gate for the signal and connects it to the very output. So yeah, we get the 29 black signal here, which is pretty useless here. We could use it in some cases, like connect it somewhere here and do something with it. If you want, you can, but this is mainly for the colors. So if I was to add some yellow color, for example, it just passes through this combinator straight to the output. So yeah, so we got the yellow character. So yeah, that's pretty much everything how it works. And yeah, the last thing I would say is there's the empty memory blueprint in the book, and with it there's everything set and ready, and you can by using the encoding I showed you, you can just create your own symbols that you want to render, and that's pretty much everything to it. You can always just disconnect this default memory and connect the empty memory, and then program it and check everything if it's working. This might be also a good idea if you want like more than only 36 characters, which is possible. I am actually working now on the beta version, which can support up to 62 symbols, I think. But for the time now, it supports only the 36, which should be enough for most cases. But if you want more, you can just like not connect the memory directly, but connect it through some gate, which will open only at certain condition. So only at certain condition it will pass everything here, and if the condition is not met, it will pass everything from here, and you just get 2 sets of memory. You can connect as many memory boxes as you want. They are pretty small, but the most time it takes to actually generate these numbers, either by hand or by writing some script which will do it for you. But yeah, it's pretty advanced technique, and uh, I think it's cool to have it like this. So yeah, if you have any questions, any comments, any feedback, it will be most appreciated. Just leave a comment down below or uh, answer the topic on the Factorio forums that I will add before the video or after the video is released. And yeah, like the video if you want. You can subscribe to this channel. I will try to maybe get up like 2 videos a month, maybe more, maybe less. I will see how my inspiration goes with new builds, and yeah, you can also request something in the comments, and I will try to make a video about it. I'm not like the most expert in the circuit networks, but I think I'm learning pretty fast now. This was like 8 hours build with even with the video recording and post writing. So yeah, feel free to subscribe if you want, and I will be happy to see you in the next video. Bye.